Well, has there been any has the climate changed in response to that? If you take the northern hemisphere temperature record and then you impose the CO2 projections from a model, this is what you get. This is basically the observations taken from a bunch of stations over the last 100 years, and this is what CO2 says. That's not very good agreement. And the question is basically why? Are the models wrong? There's certainly one possibility. I think what most people believe, however, is that it's other factors that have been causing the change. Let's quickly go through the next couple. But what one has to do, given that record, is to identify that climate has changed and then consider what these other factors are that may be having an effect. And then what you really want to do is isolate the CO2 effect. The next view graph shows some of these factors that, well, shows some ways of looking at past climate change. One of the real problems that exist is that there is not a good database to evaluate if the climate has changed. I showed you the record of northern hemisphere surface temperature, and there are some global estimates. There's a recent paper out, however, that gave quite a different pattern for the northern hemisphere surface temperatures based on ocean temperatures versus land temperatures. Somehow that's going to have to resolve. There's some historic information on snow melt and sea ice extent. There are reasonably good sea level indicators, but there's some complications that I'll get to. Sea surface temperature, the way everybody used to take it until the 50s is you threw a bucket overboard, pulled it up, put it on the deck, and then you measured the temperature. It turned out the bucket cooled off as the wind was blowing over it, so that those temperatures tend to be low, and the new way of doing it is you measure the engine injection temperature of the water. The water comes into the engine to cool it, and of course it goes to the engine room, which is very hot, and that heats it up, so some real problems with that. There really aren't very good databases to deal with. The next view graph sort of shows one of the sort of the most recent, I guess, and complete global indicators. And, this is the northern hemisphere again, although it's a slightly different domain. So it shows this, that it was quite cool late in the last century, and then you get this tremendous warming that occurred in the middle part of the record, and then it's starting to warm again in this person's record. A major problem is trying to understand what this is, what caused this warming. Hansen's suggestion, who created this record, is that it's due to a lack of volcanoes in the northern hemisphere. There's some real questions about that. Low latitudes, on the other hand, and southern hemisphere latitudes show an increase with some noise that is much more like what one might see from CO2. There's a real argument about whether you should be seeing an exponential change or a linear change also in the CO2 record. But you see a much more similar, a much more even kind of increase perhaps due to CO2. But why there would be an influence in the northern hemisphere like this that wouldn't affect the lower latitudes or southern latitudes is not at all clear. Well, let me skip the next one and go on to the next one. Well, the basic way of isolating the CO2 change then that we've got to come up with is to try and look at the CO2 results and try and basically develop a fingerprint for carbon dioxide. What are the things that have to occur due to carbon dioxide increase and the resulting climate change that are different from what happens when you have volcanic injections or changes in solar radiation or other kinds of things? Well, certainly CO2 has to increase, the tropospheric temperature has to increase, stratospheric temperature has to go down. There's some questions about, well, the infrared radiation budget has to change. If we're going to get this water vapor feedback, atmospheric water vapor better go up. There's some sense that because that CO2 will keep the nighttime temperature from becoming as cool as it does now, and there are going to be some seasonal temperature differences. But volcanoes and all these other factors also have influences, and one of the real efforts going on is to try and identify those. Let me, in terms of evidence, just look at what's happening with some of these indicators. So why don't you skip the next one and go on to the next one in the interest of time here. These are from Radiuson data for the last about 15 years. Upper atmosphere, stratosphere. The stratosphere is indeed cooling. This cooling, however, is sharper than you'd even project for CO2. So, is that good or not? And it started to increase in recent years. Is that an indicator that CO2 is changing the climate? Not at all clear. If you look at the surface temperatures in recent years, you see that in the northern hemisphere, well, this shows some warming through the 70s. This is after the cooling that was earlier, you have to explain. So there's some warming here, but you certainly don't see an amplified temperature change in polar regions. So the indications there are rather iffy. However, the next view graph shows another way of doing the northern hemisphere temperatures from Wigley and East Anglia, and he points out that this last year, 1981, was the warmest year in the last 100 years in his way of doing the calculation, which is kind of interesting. However, maybe many of you remember this winter when January, February, March was very, very cold. So everybody's sort of waiting to see what happens in 82. It'll probably be down here again and just be a blip in the noise. Let me skip that one, I think. Maybe come back to it or something. If you look at what's happening in terms of the ice, Kukla and Gavin have done some measurements in the Antarctic, and they've actually done some measurements that go back to the 1930s based on whaling expeditions that occurred down there, and they're sort of showing that the Antarctic ice is decreasing over the last 5 or 6 years. This turns out, again, to be more rapid than what one would expect from a CO2 model. And it's also occurring in the southern hemisphere and not in the northern hemisphere, where most of the models project a larger change in the northern hemisphere than in the southern hemisphere. So there's some real doubt that has to be resolved there. But indeed, ice has changed, and there's sort of a rather famous set of pictures going back to the mid-1800s about a glacier coming down on a French town, and how in the 1960s it had retreated way back up here. So climate changes can occur and do occur and can have effects. Sea level is another thing that people have been looking at. Sea level should be rising for a couple of potential reasons, it seems to be. One is just the thermal expansion of the water. As you raise the temperature, you expand the warmer water expands, and so you should get an increase of not too different than this magnitude from just the warming of the ocean water. And so there's some real interest in looking at sea level records. The real problem with sea level records is most stations are located in places like San Francisco. San Francisco's on an earthquake fault and going up and down all the time, or it's in Sweden where the land is rebounding from the last glacial age. And so you end up throwing out about 80% of the measurements, and you're left with the last 10 or 20%, and you get this nice, wonderful trend that you think agrees sort of with what you're thinking. It's kind of a dangerous thing to do. Let me skip the next one. Let me comment finally. So I guess in summary, with respect to whether we've detected the change, well, there's sort of been some warming, and it's sort of suspicious, and one can't say there's been a cooling that's in disagreement with a CO2 increase, but there's certainly not clear evidence for that CO2 has warmed the climate at the present time. A few words on effects that you've heard about, just to close based on sort of the way I began. The major kinds of influences are potentially on agricultural production, because you change the climate, which changes the temperature and the rainfall and how the crops will grow. There is a fellow from Michigan Agricultural Experiment Station named Sylvan Whitwer, who's a great advocate that agriculture in this country is technologically advanced enough that it can adapt to these changes by genetic changes in the crops and surviving on less water and things. So in a technologically advanced country, you may be able to adapt to some of these kinds of changes. In some of the underdeveloped countries where climate bands sort of shift right over the countries, you probably won't be able to do that. But they have so many other problems that most economists don't want to worry about. CO2 is a problem. CO2 also has a direct effect on agricultural production in that it's a nutrient that's required for plants and tends to enhance plant growth. And there's a sort of a major program starting to see if that occurs in the real world as opposed just into greenhouses where people actually grow lettuce and make it grow very, very rapidly. So that in deciding whether a CO2 increase and a warming are good or bad in terms of agriculture, it's not real clear with respect to climatic effects, although almost any change that you have to adapt to is a problem. In terms of CO2 increase, that'll probably be a help. It's hard to see how it can be can hurt effect. So agricultural production may not be that badly affected. The other key issue is probably this ice shelf issue, and I'll just show a last view graph on this issue. It isn't the melting of the ice that is the issue. The Antarctic is so cold right now that a little warming will allow the air to hold more moisture, and you might actually get more snow on the Antarctic continent. So it isn't the melting that is the issue. The issue is that you might not form as much seasonal sea ice. And the sea ice tends to protect the ice shelf. The ice shelf and some of the ice sheet turn out to be grounded below sea level. So if you melt back the sea ice, if you don't form the sea ice in the winter, then the water from the ocean is able to get in, the theory goes, under the ice shelf, which calves away the ice shelf, and then you lose the protection for the ice sheet, and you start calving that away. There's some suggestions that that's what happened in the final stages of the North American ice cap over Hudson's Bay, that the ice cap, that the final ice there was calved away in a time period of like 100 years because of the water being able to get in underneath. In fact, there was even, I think, on one of Walter Cronkite's shows where he interviewed, where somebody suggested that was the cause of the great biblical flood. I don't know if I can agree with that. So that this problem with respect to sea level is an interesting one. I guess I'll show what do I have? Oh, I have two more.